The Woodtec Element is a versatile assembly table designed for constructing wooden frames. Each standard module measures 1.5 by 3 meters and can be connected to additional modules of the same size. The overall table dimensions are customizable depending on the available workshop space and budget. It features a height-adjustable work surface that allows adaptation to various element sizes. An integrated clamping system ensures stability and accuracy during assembly, keeping timber components secure throughout the process. The ergonomic structure supports efficient workflows while reducing strain on workers. Designed for industrial applications, the table is compatible with CNC machines and can be incorporated into automated production lines. It enables high-precision manufacturing, facilitating the production of timber components with consistent accuracy. The secure clamping system holds elements in place, ensuring precise cuts and minimizing errors in construction. The Elementbautisch is widely used in timber construction, particularly in prefabrication and modular building. It plays a key role in producing components for timber homes, commercial buildings, and larger structures. Its ergonomic adjustments help reduce physical strain on workers, improving working conditions, and supporting productivity. Woodtec Fankhauser, a Swiss company specializing in woodworking machinery and automation solutions, has developed the Elementbautisch to support modern timber construction, addressing the growing demand for efficiency and precision in the industry. Here's some great news for builders and the environment. A team from Zurich University of Applied Sciences has developed an innovative formwork system called Unfold Form. This system significantly reduces material usage, cutting concrete consumption by up to 60% and steel by up to 90% in reinforced concrete slabs. It focuses on adaptive, foldable, and transformable structures that can change shape in response to external stimuli. The project integrates computational modeling, parametric design, robotic fabrication, and material intelligence to develop structures capable of efficient and responsive transformations. It explores kinetic and adaptive systems that react to environmental conditions such as light, heat, or user input. Using computational geometry and algorithmic folding techniques, it enables the development of origami-inspired designs that optimize material use while maintaining structural integrity and flexibility. The research also involves robotic fabrication, applying industrial robots, 3D printing, and machine learning to construct complex folding mechanisms. ETH Zurich has previously introduced robotic wire cutting, 3D knitting, and autonomous assembly, which may contribute to the project. Another key aspect is material intelligence, investigating smart materials such as shape memory alloys and programmable textiles capable of autonomous folding and unfolding. These advancements may lead to applications in self-assembling structures, robotic skins, and bioresponsive architectural facades. The initiative is likely linked to several research groups at ETH Zurich. The Gramazio Kohler Research Group specializes in robotic fabrication and computational architecture, with a focus on adaptable structures and innovative materials. The Block Research Group explores structural geometry, digital fabrication, and deployable systems. Additionally, the Computational Robotics Lab and Material Science divisions may contribute to the development of shape-shifting mechanisms and responsive materials. Potential applications include responsive architecture, deployable aerospace structures, modular furniture, and medical robotics. The research may support the development of kinetic facades that adjust to environmental changes, foldable satellite components, shape-changing furniture, and surgical robots with flexible configurations for minimally invasive procedures. The construction industry consumes up to 60% of the world's raw materials, including minerals, metals, and wood. It's essential to use these resources more efficiently. That's where the Flex system comes in. It consists of a prefabricated steel beam with an open truss structure designed to be completed with on-site concrete casting. The system includes a steel profile as the primary structural core, integrated reinforcement bars for concrete bonding, and a concrete slab or floor connection to ensure full structural performance. This system provides significant structural advantages. Its composition reduces overall weight while maintaining high load-bearing capacity. It can be adapted to different spans and load requirements, allowing for flexibility in architectural and engineering applications. The combination of steel and concrete improves resistance to seismic forces. By enabling long spans, it minimizes the need for intermediate columns, optimizing open areas. The steel framework functions as self-supporting formwork, eliminating excess on-site operations and expediting project timelines. These factors contribute to more streamlined construction with reduced labor demands. The system is applicable in various construction sectors, including commercial and residential buildings, parking structures, bridges, industrial facilities, and public buildings, such as hospitals and schools. Join the future of construction with Hilti Jaibot. This robot helps drill and mark holes. The operator guides it with a remote, and then Jaibot takes over, working on its own to drill and mark all reachable holes. It operates using preloaded digital drilling plans from building information modeling data, ensuring precise hole placement in concrete ceilings. Equipped with a laser scanning system, it aligns itself with the BIM model and moves automatically to predefined drilling positions, eliminating the need for manual marking and measuring. It features a hands-free overhead drilling mechanism that reduces worker fatigue and minimizes the risk of injuries linked to manual drilling. An integrated Hilti VC40M vacuum system captures up to 90% of drilling dust, helping maintain cleaner job sites and reducing airborne particles. This robot is powered by Hilti's Neuron battery platform, allowing it to function without external power sources while moving between drilling locations. Cloud-based connectivity enables the Jaibot to sync with Hilti's OnTrack and BIM platforms, providing real-time project data reporting and remote monitoring. It increases efficiency by drilling up to 500 holes per shift, while reducing physical strain on workers. The design eliminates the need for scaffolding and ladders, lowering fall risks and supporting workplace safety regulations. In Singapore, the construction industry is incorporating more automation to align with Industry 4.0 and the Building and Construction Authority initiatives aimed at improving digital construction and reducing dependency on manual labor. The Hilti Jaibot supports these developments by streamlining overhead drilling, increasing precision, and improving worker safety. Its ability to carry out dust-free and automated drilling operations makes it a practical solution for modern construction projects. The Steck-Box is a simple yet efficient solution for forming niches and gaps in concrete ceilings and walls. Constructed from plastic components, it consists of modular wall elements in 3 standard widths: 15, 20, and 25 centimeters, and heights ranging from 18 to 32 centimeters. These components can be arranged in 90 or 180 degrees configurations, allowing for opening sizes between 15 by 15 and 50 by 50 centimeters. This modular approach allows for quick adaptation to various construction requirements. Installation is designed to be efficient. The wall elements are connected to achieve the required opening dimensions and secured with a 2 cm high cover on the formwork using aluminum nails. This method eliminates the need for complex formwork and reduces assembly time. Once the concrete has set, the Steck-Box remains embedded, avoiding the need for removal and disposal of materials like wood or styrofoam. When installed with the tested cover at ceiling level, it complies with SUVA Rule 2 of the 8 Essential Rules for Building Construction. This ensures that no additional tripping hazards are introduced, the cover remains securely fixed, and formwork panels are not required, improving safety on site. Once the cover is removed and necessary, installations such as plumbing, electrical, or heating systems are in place. This modular system tackles a range of challenges and provides builders with smart solutions. For example, the roll lock technology enables beams to automatically position and lock in place using gravity. The tough polymer inserts are designed for nailing, and none of the lightweight aluminum components of PERI SKYFLEX exceed 22 kilograms. For more, the handy assembly tool eliminates the need for ladders, allowing 2 workers to complete the setup from the ground. The system adapts to different slab thicknesses and floor layouts while maintaining structural integrity. The main components include aluminum panels that interlock to create stable slab support, a drophead system that enables early removal of panels while keeping props in place for curing, and adjustable support props that provide reliable load-bearing capacity. Panel connectors and edge beams ensure precise alignment, while integrated safety features such as anti-drop protection and guardrails contribute to a secure work environment. This system increases efficiency by reducing the number of individual components needed. Large format panels simplify the formwork process, while the drophead mechanism allows for early striking, helping projects stay on schedule. The adaptable nature of the system allows it to accommodate irregular floor plans and integrate with other PERI systems. It is designed for repeated use, as the aluminum panels can withstand multiple construction cycles, significantly reducing material waste. Unlike traditional timber formwork, the system has a longer lifespan, leading to long-term cost savings. The reduced manual handling required also contributes to improved workflow on site. Walls made from RIGIPS panels are an excellent choice for environments such as schools and hospitals due to their strong impact resistance and advanced edge protection. Additionally, these panels provide up to 90 minutes of fire resistance and perform well in moisture-prone areas like kitchens and bathrooms. If a height of 3 meters does not suffice, custom orders can be arranged to accommodate specific requirements. It consists of a reinforced gypsum core with integrated cellulose fibers and specialized additives, providing increased strength, fire resistance, impact resistance, moisture protection, acoustic insulation, and the ability to support mounted fixtures. Unlike standard gypsum boards, it has a uniform composition without a paper lining, resulting in improved mechanical properties and long-term stability. Moreover, it can support mounted elements such as televisions, shelves, cabinets, and handrails without additional reinforcements. The board allows direct screw attachment in many cases, simplifying the installation process. With moisture-resistant properties, it is also suitable for areas exposed to humidity, including bathrooms, kitchens, and basements. If building parts are not constructed carefully, thermal bridges can form. This allows heat to escape through connections, such as where a balcony meets a slab. As a result, issues like mold or cracks in the concrete may develop. To prevent this, builders use thermal insulation systems to separate these elements from the building's thermal flow. It integrates high-density insulation materials with load-bearing elements, such as steel rebar, stainless steel, or fiber-reinforced polymer to separate interior and exterior structural components while ensuring safe load transfer. The system is compatible with concrete, steel, and wood construction and is used in applications such as balconies, slab edges, parapets, canopies, walkways, roof overhangs, and column connections. Thermal bridging occurs when conductive materials like concrete and steel bypass insulation, leading to heat loss, increased energy consumption, and condensation risks. Schöck Isokorb significantly reduces heat transfer, lowering thermal bridges by up to 90%. This contributes to better energy efficiency, lower CO2 emissions, and compliance with building performance standards, including LEED and Passive House certifications. Beyond thermal insulation, Schöck Isokorb contributes to structural integrity by transferring shear, tension, and bending loads between connected elements. It meets or exceeds North American and European building codes. The system also helps maintain stable surface temperatures, reducing the likelihood of cold spots that can cause condensation and mold formation. By limiting moisture-related damage, it extends the lifespan of buildings and reduces the need for expensive repairs associated with thermal stress. Adding optical fibers to concrete allows it to transmit light. This is not a joke, but a real building material that is already being mass-produced. For ease of use, it is available in panels, with one example measuring 120 by 65 by 3 centimeters. These fibers, approximately 70 microns in diameter, are placed within the concrete matrix, allowing both natural and artificial light to pass through. This process results in illuminated surfaces while maintaining the strength and structural properties of traditional concrete. The manufacturing method requires precise placement of the fibers, with factors such as distribution, flow velocity, and ambient temperature influencing the final outcome. Lucem offers several product lines designed for different architectural and design purposes. Lucem line arranges optical fibers in a linear pattern within a fine-grained marble concrete matrix, creating structured lighting effects. Lucem Starlight incorporates fibers of varying diameters, positioned randomly to produce a three-dimensional star-like illumination. Lucem Pure is a solid concrete panel without optical fibers, allowing for combinations of translucent and opaque elements within a design. Lucem 1 consists of prefabricated elements such as cube lamps and wall sconces, using the Lucem line design to provide ready-to-install illuminated objects. This material is used in various architectural applications. It serves as wall cladding, floor tiles, countertops, and decorative features, creating a distinctive visual effect through the passage of light. In exterior applications, it transforms facades into illuminated surfaces, particularly when combined with programmable LED systems. Additionally, it is incorporated into furniture and lighting fixtures, integrating illumination with structural elements. The integration of optical fibers into concrete introduces new possibilities for design and architecture. Whether applied in buildings, furniture, or lighting, this material introduces a visual element that interacts with its surroundings through transmitted light, combining structural reliability with an aesthetic feature. PERI ALPHAKIT is a modular scaffolding and shoring system designed to support high loads while allowing for flexible configurations in construction. Constructed from aluminum or high-strength steel, it ensures easy transport and handling without compromising stability. The system efficiently distributes heavy loads, making it applicable for shoring in bridge construction, industrial structures, and large-scale infrastructure projects. With a modular setup, it can be adjusted to different project requirements, reducing excess material usage. Capable of spanning up to 28 meters, it provides reliable structural support across various applications. Engineered to comply with European safety standards, including EN 12812 for falsework and scaffolding, the system integrates key safety measures such as guardrails, secure connectors, and adjustable components to maintain stability and worker protection. Assembly is simplified with the use of pins instead of bolts, preventing issues with stripped threads and allowing for faster connections with a hammer strike. The design allows for pre-assembly without the need for a crane, improving efficiency on site. The ALPHAKIT is effective in bridge and tunnel construction, supporting the rapid setup of shoring towers and load-bearing structures for bridge piers. It is also used in high-rise construction, industrial maintenance, and viaduct projects, offering stable access and dependable reinforcement. The efficient assembly process minimizes labor demands and accelerates project timelines, contributing to overall cost and time savings. JUUNOO designs reusable walls featuring an innovative adjustable frame. Their patented telescopic system makes height adjustments simple and fast, even for those working solo without construction experience. They can be installed up to 7 times faster than traditional drywall and adjusted or relocated without producing waste. These walls offer acoustic insulation, making them a practical choice for offices, commercial spaces, and co-working environments. Various finishes, including wood panels, laminate, painted surfaces, wallpaper, and acoustic panels, allow for customization to match interior design preferences. The system is height-adjustable, modular, and capable of supporting mounted items such as whiteboards or screens. Developed by the Belgian company JUUNOO, these partitions follow a circular economy approach, reducing construction waste. Unlike conventional drywall, which is often discarded after a single use, these walls can be disassembled and reused, contributing to long-term cost savings. A buyback program is available, allowing materials to be repurposed rather than discarded. Installation requires minimal tools and no wet materials like plaster or paint. This results in lower costs associated with assembly, reconfiguration, and removal compared to traditional partition systems. The walls provide effective sound insulation, with performance varying based on the selected finish and additional acoustic treatments. Common applications include offices, retail spaces, and other commercial environments that require flexible layouts. The ability to reconfigure the partitions without structural modifications allows businesses to adjust their interiors as needed. We are in the United Kingdom, or more specifically, underground in a tunnel. This tunnel is part of the London Power Tunnels project, a vital component of the UK's electrical grid. Every task here demands full concentration to avoid mistakes. The company overseeing the work, Balfour Beatty, utilizes an AI-powered robot that detects cable slack with exceptional precision. With 200 kilometers of cables still to be installed, these experts and their advanced technology have a challenging task ahead. The system incorporates AI-powered cable management, real-time monitoring, and predictive maintenance. AI algorithms analyze environmental factors such as terrain and temperature to adjust cable positioning, tensioning, and placement dynamically. Robotic arms and mechanized rollers handle cables, while automated spooling mechanisms prevent overstretching. Precision-guided movement allows operation in complex environments without manual intervention. The system includes advanced sensors such as LiDAR, infrared, and pressure sensors to scan and map cable routes with high accuracy. Automated obstacle detection allows it to identify and navigate around barriers, while temperature and load sensors prevent overheating and mechanical stress. Operators can control and monitor the equipment remotely, using an AI-driven dashboard that provides real-time updates, analytics, and system alerts. Integration with building information modeling allows for planning and simulation before installation begins. AI-driven learning continuously improves performance by detecting wear and tear and using predictive maintenance algorithms to prevent delays. This technology plays a key role in railway electrification, streamlining the installation of overhead and underground cables. It is also used in infrastructure projects such as highway and tunnel electrification and supports utility networks. XYZ is an augmented reality system that shows a BM model on a construction site. Inspectors wear special glasses to spot issues quickly. For example, they can see if a duct is 28 centimeters too long or if a bolt is loose. It integrates with the Atom, an augmented reality headset, allowing users to view and interact with 3D BIM models directly on site. With millimeter-accurate model alignment through advanced georeferencing and tracking, it ensures precise placement of structural elements, mechanical, electrical, and plumbing systems. The system supports real-time clash detection and issue resolution, identifying discrepancies between design models and actual builds before they become costly errors. The platform enables automated progress monitoring by comparing digital models with physical structures, generating real-time reports without the need for manual inspections. It works with industry-standard BM software such as Autodesk Revit, Navisworks, and IFC formats, allowing smooth workflow integration. Users can walk through construction sites with AR overlays, ensuring components are installed as planned. Remote collaboration tools allow teams to track issues, assign tasks, and share updates instantly, reducing the need for frequent site visits. The digital workflows improve coordination across all project phases. By replacing traditional paper blueprints with AR-driven verification, it minimizes misinterpretations that lead to costly rework. With real-time validation, errors can be addressed before they cause project delays or budget overruns. The elimination of manual measurements and inspections speeds up processes while maintaining accuracy. The Hobbs formwork system may appear lightweight and simple at first glance. It might even resemble construction for small-scale models, as it is made from plastic and expanded polygene foam. However, this system is highly effective and is recommended for areas that experience strong winds and seismic activity. Unlike conventional horizontal blocks that require staggered placement, this system utilizes vertically oriented expanded polystyrene foam panels connected with internal web ties, allowing for full-height continuous concrete pouring. This method improves structural integrity by eliminating cold joints and weak points, resulting in a stronger monolithic concrete wall. The EPS foam panels provide high thermal insulation, reducing thermal bridging and increasing energy efficiency, with R values typically ranging from R22 to R30+, depending on foam thickness. The system minimizes heat loss, lowers heating and cooling expenses, and is appropriate for net zero energy homes and commercial buildings. For more, the dense concrete core and EPS panels contribute to soundproofing and fire resistance. This system also offers greater resistance to seismic activity, strong winds, hurricanes, tornadoes, and impact damage compared to traditional construction methods. Installation is significantly faster and more efficient due to the vertical design, which reduces bracing requirements and simplifies the alignment process. Contractors can place and secure panels quickly, cutting down labor time and material waste. Once the panels are set, internal ties and rebar reinforcements are added before a single, continuous concrete pour completes the wall structure. The walls can be finished with stucco, brick, stone, siding, or interior drywall, making them adaptable for various architectural styles. The Superdust Deputy 45 Cyclone is an excellent option for both small and large woodshops. This cyclone separator efficiently removes dust and debris from the air, ensuring cleaner workspace conditions. With a 99.99% purification rate, it effectively traps fine dust, preventing filter clogs and enhancing air quality. Constructed from reinforced molded resin, it separates dust and debris before they reach the dust collector's filter. This process reduces clogging, maintains airflow, and extends the filter's lifespan. It is compatible with 4-inch and 5-inch dust collection hoses, and effectively handles both fine dust and larger debris like wood chips. By using centrifugal force, it spins dust and debris away from the main airflow and directs them into a separate collection container, such as a drum or bucket. With an airflow capacity ranging from 350 to 700 cubic feet per minute, depending on the connected dust collector, it helps maintain suction and reduces pressure loss. The outlet has a 5-inch diameter, while the waste port measures 6 inches, allowing for easy attachment to a dustbin. Installation requires placing the Cyclone on a sealed collection drum or custom-built container. Hoses must be connected securely, with the Cyclone's outlet leading to the dust collector and the inlet connecting to dust-producing tools. Sealing all connections with silicone or weather stripping helps prevent air leaks that could reduce efficiency. Once installed, the system directs debris into the collection bin instead of the dust collector. MycoTile develops sustainable construction materials using mycelium, the root-like structure of fungi, to create eco-friendly building solutions. Through biofabrication, mycelium binds organic agricultural waste, such as rice husks and coffee husks, into solid structures without synthetic resins or chemical adhesives. This process results in a material with strong structural integrity, natural insulation, and resistance to fire. Chitin, a biopolymer found in mycelium, slows combustion without requiring harmful additives, while the absence of synthetic chemicals contributes to environmental safety. The manufacturing process significantly reduces resource consumption, using 50% less water and 80% less energy compared to traditional insulation and roofing materials. The method involves preparing a substrate of agricultural waste, introducing mycelium spores, allowing the material to colonize under controlled conditions, molding it into various forms, and applying heat treatment to stop fungal growth. This eliminates the need for carbon-intensive manufacturing and minimizes ecological impact. Originally focused on insulation, MCO is expanding its range of applications. Planned developments include biodegradable construction blocks as an alternative to concrete, mycelium-based MDF replacements for engineered wood products, and furniture or decorative panels that support compostable carbon-negative solutions. As demand grows for materials that reduce deforestation, emissions, and waste, mycelium-based products present an alternative to conventional construction methods. NetOp is a reliable safety system designed to protect workers operating at heights. The basic kit has a total weight of 14 kilograms and can be packed into a backpack, allowing a single worker to carry it without difficulty. It can be fully set up in just 5 minutes, minimizing delays and ensuring work can begin promptly. The system is designed for use in roof repairs, solar panel maintenance, and general construction, providing full protection while increasing stability and precision. The structure consists of a net with crosshairs, offering secure support without being difficult to handle. Unlike larger and more complex safety solutions, NetOp's compact design allows for easy transportation and quick installation. With minimal effort, workers can set it up and focus on their tasks without unnecessary interruptions. Once in place, it provides a stable working environment, helping workers maintain focus and accuracy in elevated positions. Ideal for professionals in roofing, solar installation, and maintenance work, it serves as a dependable solution for reducing fall risks. Next, we have chemical anchors, which are used to secure rebar, threaded rods, and other components with a specialized bonding compound. Depending on their composition, some chemical anchors can even function underwater. They are also particularly useful when dealing with oversized or irregularly shaped holes. It operates as a torque-controlled expansion anchor, expanding within the concrete when tightened to provide a secure hold. Engineered for demanding structural applications, it has a high load-bearing capacity and is resistant to shear and tensile forces. Fire-rated versions are also available for use in environments exposed to high temperatures. This anchor allows for through-fixing installation, meaning it can be inserted directly through the fixture without pre-positioning. It is produced in different material options, including zinc-plated steel, stainless steel, and hot-dip galvanized steel, offering resistance to corrosion. Diameter options typically range from M8 to M20, with various lengths and embedment depths to accommodate different load requirements. Common applications include securing steel frameworks, concrete columns, beam fixings, and facade installations. It is frequently used in industrial and infrastructure projects such as bridges, tunnels, railway and metro systems, as well as in heavy machinery anchoring, storage rack installations, and safety barriers. Additionally, it is applied in securing industrial pipe supports and other critical structural components. The installation process involves drilling a hole in the concrete to the specified diameter and depth, cleaning the hole to remove dust and debris, inserting the anchor through the fixture, and tightening it to the recommended torque. This causes the expansion mechanism to activate, securing it within the concrete. Strama is a facade finishing system designed for buildings with polystyrene or mineral wool blocks. It is installed using a dry process and is so simple to set up that the tutorial video is only 38 seconds long. The panels are primarily made of aluminum with a wood veneer top layer, ensuring durability, easy maintenance, and over 100 design options to match various preferences. They feature high-quality window veneers that replicate the natural look of wooden boards, combined with aluminum construction for strength and resistance to wear over time. Installation is designed to be fast and efficient, using the SEMS LM mounting strip for a dry-fitting method that allows panels to be arranged both horizontally and vertically in various configurations. The dry-therm insulation system incorporates the SEMS assembly method, allowing thermal insulation with polystyrene or mineral wool. The same system is used to install the panels on pre-insulated walls. Wood-like finishes are particularly recommended for renovation projects, restoring the classic appearance of historical buildings while maintaining the benefits of contemporary materials. These panels also bring a refined look to small commercial properties such as beauty salons, retail spaces, and car showrooms, giving them a more polished and appealing exterior. ValkScreenVision 2.0 is an advanced greenhouse screening system developed by Van der Valk Horti Systems to improve climate control, energy efficiency, and light management. It optimizes light distribution within the greenhouse, supports shading, heat retention, and diffusion, and works with various screen fabrics, including shading, thermal, and blackout screens. By reducing heat loss in colder conditions, it lowers energy consumption and helps growers manage heating and cooling costs effectively while promoting sustainable agricultural practices. Equipped with high-precision guiding and tensioning mechanisms, it allows for smooth and accurate screen movement while minimizing wear and tear. This reduces maintenance needs and extends operational life. Designed for both horizontal and vertical screening applications, it fits different greenhouse structures. The components resist corrosion and withstand high humidity and temperature fluctuations, ensuring reliability in demanding environments. The system adapts to various installation configurations such as top screens, side screens, and rolling screens. It is available in different sizes and styles to suit specific greenhouse layouts and crop types. It integrates with climate control systems to automate shading and ventilation processes, improving efficiency in greenhouse operations. By regulating temperature, humidity, and light levels, it contributes to optimal conditions for plant growth. It helps maintain consistent photosynthetic activity by adjusting sunlight exposure. Its insulation properties support lower energy expenses by improving thermal retention. The system is designed to support sustainable agricultural methods by optimizing resource use while improving growing conditions. SureBrick provides all the advantages of traditional brick without sacrificing the building's architectural integrity. It works through a specialized system of profiles that securely hold the bricks in place using a mechanical fastening method. It consists of real clay brick slips that are cut or manufactured into thin sections and secured onto a metal rail system. The installation process involves fixing the metal support structure to the subframe, attaching the brick slips, and applying mortar or jointing material to complete the finish. This method allows for prefabricated assembly off-site or direct installation on-site. Engineered for modern construction, SureBrick reduces build time compared to conventional bricklaying. It lowers on-site labor requirements, making it an effective solution for modular and off-site construction. The system is designed for long-term stability, with resistance to various weather conditions. Its composition also reduces structural load, which is beneficial for high-rise developments. For more is produced in multiple brick types, colors, and finishes, allowing it to fit different architectural styles, from contemporary designs to traditional aesthetics. It is used in high-rise buildings, modular housing, residential developments, commercial properties, and refurbishment projects. The system is particularly useful in large-scale construction, where speed and efficiency are priorities. It can also be installed on existing structures to improve appearance and insulation. Fast-moving water carrying solid particles can wear down surfaces like sandpaper. Chemicals in crevices may lead to corrosion, and shrinkage can also be an issue. Sewer and wastewater systems expose concrete to harsh conditions, so applying a protective coating, such as Sikagard, will protect it. It is a range of protective coatings, sealers, and treatments developed to improve the performance and longevity of construction materials such as concrete, masonry, steel, and industrial flooring. These coatings provide resistance against environmental exposure, mechanical stress, moisture infiltration, chemical attack, and microbial growth. Sikagard coatings for concrete help prevent deterioration caused by carbonation, chloride penetration, and water ingress. Sikagard 550W elastic offers crack bridging properties and UV resistance, while Sikagard 705L and Sikagard 706 Thixo use silane-based hydrophobic technology to reduce water absorption while maintaining breathability. For protection against graffiti and microbial contamination, Sikagard includes coatings designed to resist stains, mold, and bacteria. Sikagard 850 AG forms a permanent transparent layer that allows for easy removal of graffiti, while Sikagard 207W Hygiene and Sikagard 205W contain antimicrobial properties, making them suitable for healthcare, pharmaceutical, and food processing environments. Sikagard corrosion protection solutions help prevent rust, oxidation, and chemical damage on steel and metal surfaces. Sikagard 63, N and 62 are epoxy-based coatings designed for steel structures, pipelines, and industrial equipment exposed to harsh conditions. These coatings are applied in industrial plants, chemical storage tanks, and offshore structures. Waterproofing and damp-proofing coatings, such as Sikagard 905W and 703W, provide resistance to moisture infiltration, mold growth, and efflorescence. They are applied to basement walls, facades, and underground structures. Detecting gas leaks and identifying discharge points is much easier. Simply walk around the inspection area, and the camera's microphones will capture sounds within the 2 to 65 kHz range, displaying the results on screen in a way similar to a thermal camera. It features 124 MEMS microphones that capture high-frequency sound waves, converting them into a visual sound map overlaid on a real-world image. This allows for real-time identification of pressurized leaks with improved accuracy, even in loud industrial settings. The device incorporates AI-driven leak quantification, automatically estimating leak size, classifying severity, and calculating energy loss and cost impact. The FLIR acoustic camera viewer software provides cloud connectivity for data storage, automated report generation, and long-term leak analysis. Data can be exported in PDF or image formats, assisting with maintenance planning and compliance documentation. It weighs 980 grams and supports one-handed operation. A large touchscreen interface allows for simple navigation, while its ergonomic design accommodates extended field inspections. The device can also be mounted on a tripod. Beyond compressed air leak detection, applications include vacuum system maintenance, gas leak identification in industrial plants, and electrical partial discharge detection. By providing a visual representation of leaks, the FLIR C124LD+ simplifies inspections and reduces the time. This enables industries to improve efficiency and reduce energy waste. MSE blocks arrive at the construction site, prepped for use as parapets, tailored to meet the unique requirements of each project. For example, on a bridge, they can be modified to accommodate railings, streetlights, and drainage systems. Their availability in non-standard shapes makes them a versatile choice, helping workers save both time and effort, regardless of the design. These panels are commonly used in highway and infrastructure projects and adhere to Florida Department of Transportation specifications. Designed to withstand environmental conditions, they contribute to safety in transportation structures. Manufactured using reinforced concrete, these panels have a minimum compressive strength of 4,000 to 5,000 psi. Reinforcement is provided through embedded rebar or mesh to minimize cracking and structural stress. Attachment methods vary, with some panels cast directly into the wall during installation, while others are fastened using bolts, grout, or embedded anchors. Certain designs incorporate drainage slots or weep holes to regulate water runoff. These panels serve multiple functions, including protecting the top of retaining walls from erosion, weather exposure, and mechanical impact. They provide a continuous and uniform surface at the upper edge of MSE walls, contributing to structural integrity while improving visual appearance. In transportation settings, they may also be used to support safety barriers or pedestrian railings when necessary. Sunflare has spent years developing advanced solar panels, resulting in significant improvements. Their panels are 10% more efficient, 65% thinner, and 86% lighter compared to many others on the market. Designed without glass, they are highly flexible and can be installed using double-sided adhesive tape. In terms of efficiency, a single Flex 60 panel, measuring 3.28 feet by 5.41 feet, can generate up to 180 watts of power. To demonstrate their versatility, these panels were installed on a Tesla Cybertruck, producing 1.5 kilowatts of solar power per hour. These panels do not require glass or aluminum frames and can bend to fit curved or irregular surfaces. Installation is simplified since no racking system is needed. They maintain efficiency even in low light conditions and partial shading, unlike traditional silicon panels that lose performance when obstructed. Using its patented Capture 4 process, Sunflare applies ultra-thin layers of CIGS onto a flexible stainless steel substrate. Unlike conventional silicon panels that rely on high-temperature vacuum chambers, this method consumes less energy and lowers production costs. These solar panels serve multiple purposes across different industries. For transportation, they provide an alternative energy source for RVs, motorhomes, semi-trucks, boats, yachts, and electric vehicles, potentially reducing fuel consumption and extending battery range. Off-grid uses include emergency power during disaster relief, support for military operations, and electricity generation in remote locations where standard solar panels may not be practical. The ECOncrete team united engineers, urban planners, biologists, and other experts to develop innovative solutions. One of their creations is these specialized mats, made from a unique type of concrete that has been tested and proven safe, even in tropical waters. The design includes biosupportive admixtures that adjust pH levels to encourage marine life, textured surfaces that facilitate the growth of organisms such as corals, oysters, and barnacles, and a structural layout that reduces water turbulence and creates shelter for marine species. Traditional concrete often has negative effects on marine ecosystems, while ECOncrete ACMs encourage biological growth. Over time, marine organisms settle on the concrete, forming a natural protective layer that strengthens the material. This biological activity also helps filter pollutants, contributing to improved water quality. The materials used in production are selected to reduce environmental impact compared to standard concrete. ACMs are applied in various marine and coastal projects, including shoreline stabilization to limit erosion and encourage habitat formation. They also provide scour protection for underwater infrastructure such as bridge piers, offshore wind farms, and pipelines, reducing sediment displacement. Additionally, they support coastal restoration by balancing human development with marine ecosystem needs. Tekcrete Fast is a rapid-setting dry mix shotcrete developed by Minova for structural support in mining, tunneling, and underground construction. It reaches over 3,000 pounds per square inch compressive strength within 1 hour and 8,000 to 10,000 pounds per square inch in 28 days. With a quick setting time, it can be applied within minutes, allowing for immediate stabilization. Reinforced with steel or synthetic fibers, it improves tensile strength and impact resistance. The material has low rebound, reducing waste, and adheres strongly to rock, concrete, and other surfaces. It is resistant to sulfates, chemicals, and shrinkage, making it effective in harsh underground conditions. The composition includes Portland cement, selected aggregates, fiber reinforcements, accelerators, and additives. The dry mix shotcrete process allows efficient application, as the material is pneumatically conveyed through a hose with water added at the nozzle for controlled hydration. The mixture bonds well to vertical and overhead surfaces without excessive sagging, making it effective for structural reinforcement in demanding environments, for more is applied in underground mining for ground control and emergency stabilization, in tunneling for linings and structural repairs, and in civil infrastructure for bridge, highway, and dam restoration. It is also used for rock stabilization, landslide prevention, and reinforcement of high-impact structures, including industrial and military applications. Proper safety measures are required during application, including dust control and the use of personal protective equipment such as respirators, gloves, and eye protection. The material should be stored in a dry environment to prevent premature hydration. Although it sets quickly, applying curing methods like water misting can help improve long-term performance and structural integrity. Old tires can be reused in construction by taking advantage of their strength and availability. One approach involves filling them with rubble and sealing them with a concrete mixture, forming solid walls that can be used in various building projects. Another method incorporates whole tires into wall structures, offering a practical way to repurpose discarded materials while contributing to insulation and stability. Tires can also be processed into smaller pieces and blended with asphalt, which helps improve road surfaces by increasing flexibility and impact absorption. This reduces strain from constant traffic and temperature changes, making roads more resistant to cracks and general wear. Beyond road construction, old tires have been used in retaining walls, erosion control systems, and even sound barriers. Their ability to absorb shocks and resist degradation makes them a suitable material for structures that require long-term stability. When stacked and properly secured, they can be used in earthship homes and other alternative housing solutions, providing insulation and structural integrity. Tire-based construction methods have been explored globally as part of sustainable building efforts. Their widespread availability offers an opportunity to reduce construction costs while minimizing environmental impact. By repurposing tires in walls, roads, and other structures, communities can find practical solutions to waste management and material shortages. Further research and development may lead to new ways of incorporating them into modern construction without compromising safety or efficiency. The Sika Seismic Joint System is an expansion joint solution designed to accommodate movement in structures caused by seismic activity, temperature fluctuations, wind loads, and general structural shifts. It is developed to maintain water tightness, fire resistance, and long-term performance while allowing buildings and infrastructure to adapt to environmental stresses. The system includes pre-compressed, impregnated foam seals, and hybrid expansion joints that absorb movement in multiple directions. These materials create a continuous barrier against water infiltration, eliminating the need for additional drainage systems. Several models also include fire-resistant properties, meeting UL 2079 and ASTM E1966 standards with fire ratings of up to 4 hours. Resistance to UV exposure, temperature variations, and chemical exposure contributes to the system's reliability, while some models are suitable for areas with high pedestrian and vehicular traffic. Installation is simplified through pre-compressed foam components and factory-fabricated transitions that adapt to complex structural layouts. Sika M-Seal offers various models tailored to specific applications. The Seismic Color Seal is a pre-compressed joint with a silicone-faced, impregnated foam sealant that allows for movement absorption while maintaining resistance to water and UV exposure. The M-Sealed DFR and WFR integrates fire resistance with a watertight barrier, making it applicable to structures such as hospitals, stadiums, and commercial buildings. The BJS, Bridge Expansion Joint System, is designed for infrastructure projects, including bridges, highways, and tunnels, offering resistance to environmental conditions and vehicular traffic. The Tassu prefabricated footing mold provides a quick and efficient solution for constructing strong foundations. It is pre-reinforced, measures 5 meters in length, and weighs 20 kilograms. Designed for efficiency, it allows footings to be prepared and poured within a single day. The mold is easy to handle, simple to install, and adapts to different ground levels without additional effort. Suitable for residential construction, including industrial and office buildings, it simplifies the foundation process and reduces overall construction time. The prefabricated structure reduces labor while maintaining a high standard of quality. Its precise manufacturing supports a reliable foundation system that aligns with modern construction needs. Tassu molds contribute to a fast installation process, serving as an alternative to traditional foundation methods. The ready-to-use mold structure simplifies foundation work while maintaining strength and stability. The system integrates well with different project requirements, allowing it to be applied across various construction types. For professionals, all necessary product details and technical documentation are available in the Lammi ProdLib product library. This digital resource includes planning materials in an organized format, helping with design, selection, and implementation. Many companies have used Tassu footing molds in their projects, noting the ease of use and effectiveness. The product has been successfully implemented in different construction types, demonstrating its practical value in foundation work. Geoweb system is a geosynthetic soil stabilization solution that uses three-dimensional geocells to confine and reinforce infill materials such as soil, aggregate, or concrete. Manufactured from high-density polyethylene, it features perforated and textured cell walls that improve frictional interaction and drainage. The system is available in multiple cell depths ranging from 3 inches to 12 inches and exhibits high environmental stress crack resistance, exceeding 5,000 hours. It has a predicted lifespan of over 100 years in natural soil conditions and is designed with ultrasonically welded seams, providing a short-term peel strength of over 72.5 pounds across a 4-inch width. In load support applications, the system stabilizes infill materials, reducing lateral movement and distributing loads efficiently. It is commonly applied in unpaved roadways, parking areas, and base reinforcement under paved surfaces. By allowing the use of locally available infill, it reduces the need for imported aggregates while maintaining strength. For slope protection, the system secures the upper soil layer, preventing erosion and allowing for steeper slope designs compared to unconfined soil. It supports different infill materials such as vegetation, aggregate, or concrete based on project requirements. The structure limits surface erosion, controls rill formation, and improves slope stability, particularly in areas exposed to concentrated water flow. In hydraulic applications, the system reinforces channels by securing the channel lining and reducing erosion caused by high flow velocities. When used with suitable infill and turf reinforcement, It withstands flow velocities up to 30 feet per second. Retaining walls constructed with the system utilize stacked geocells to create flexible, permeable structures that conform to terrain variations and accommodate differential settlement. These walls can incorporate vegetation for environmental benefits, supporting a range of civil engineering applications with effective structural performance.